Good afternoon, everyone. Can someone online let me know if you can hear me clearly, please?
Good afternoon, ma'am.
Afternoon.
Good afternoon, ma'am.
All right. Okay, so we're gonna pick back up from where we left off. Just a few housekeeping matters before we begin. I would have mentioned online that your tutorials do not start this week, they start next week, but your practicals will start this week. Your practicals will follow pretty much the same format as the lectures. Some of you can choose to come face to face. I think they're supposed to be face to face. But if you desire, you can follow on Zoom because a Zoom link will be provided. Right, but the tutorials will start from next week. And again, the tutorials are entirely online. Please make sure that you check the announcements chat regularly because that's where I post all of my information. I find a lot of people tend to email me the same questions that I have answered. Just hold a second. All right, just 1 second. I'm gonna try to start it up. Some people are telling me that that it's very low, and somebody said the audio distorted. Are the people online? Tell me if you can hear me any better now.
I could hear very good. I don't know if there's anybody else.
Yes, it's clear.
We could hardly hear you, ma'am.
Just 1 second. So where should I place it? Is that any better? No. It doesn't. All right, tell me if that's any better.
I'm not doing anything.
A little bit, thanks.
Okay. All right. As I was saying, just make sure that you check the announcements to be able to get any information because I find that a lot of people are emailing me, asking me the same questions that I have put in the announcements. There's something else I wanted to address. Your tutorial will be posted a little bit later this evening. It will be based on the information, what we have done so far, and your tutorial questions are going to be different from your practical questions. So remember the format for the practical. You're going to get some questions that you're going to do without having the questions before. You're going to do them immediately in the class, but the tutorials, you will have a chance to prepare the material and ask the tutors, who will be me and one other person, for assistance. Hopefully with this ring you can still hear me clearly, but I will try to speak as much as I can.
Again and do my class and leave work. All right, later.
Last class, we would have stopped at indices. I wanted to go over a few things before I continue, just recap a few things for you. And I also wanted to give you some rules. So before I give you the rules, which is something you will have to write down, they're not given in your notes. I just wanted to go over a few things that I need to make sure that you're clear on before I move on. So the first is that remember, if we have a group of numbers which are positive and negative. For instance, negative 9 plus 3 minus 7 minus 6 plus 2. Even if these are fractions, so let's imagine these are fractions, it's 9 over 10, 3 over 5.
Try talking with it here.
Okay, is this better for you to hear? I don't think so.
No, fine. It's somewhere about how you're putting it. That's uncomfortable.
Yeah, that's fine. Can we hear clearly now? Right.
Yes,
So
please.
Loud and clear, ma'am.
let's turn this into a fraction. And we're not actually going to work it out, but I'm just giving you an example. So just remember that we always group together our negative numbers and we add them. If you have a negative and a positive number, you subtract them and put back the sign of the biggest number. So in this case, what you would do is that you would group together all of the negative numbers. So that would be negative 9 on 10, negative 7 on 5, negative 6 on 7. And you would, what you're really going to do is that you're going to keep a negative sign at the front, but you're going to really add these together. If I give you a simpler example, if I give you negative 2 plus 3 minus 5 minus 6 plus 7, again, just group together your negative numbers and add them. So I'll put a negative sign at the front and I'll add 2 plus 5 plus 6. And for the positive numbers,
It got a jam.
add those together.
It stayed with you this morning.
2, 5, and 6, that will give me 13. So I will have negative 13. And over here I get 10. And once you get to this stage where you have a positive and a negative number, you always subtract them and put the sign in the bigger number. I just want to make sure that's clear. So your answer here,
Excuse me, ma'am. Hello?
I'm listening. Go ahead.
Someone mic is on and they can hear everything in the background. She's cutting up half of what you are saying.
Hi, excuse me, ma'am.
Yes, please.
Question. You said adding negative 13 plus 10. You said you just subtract the 10 from the negative 13, and that's how you got the 3?
Yes. And I'll put back the sign of the bigger number. So it'll be a negative 3.
Okay.
The person's mic is off because I didn't see anyone's mic off just now. Did the person mute it already? Or you can still hear something?
I believe it's now off. I'm not hearing the feedback anymore. Thanks.
So that is no problem. So that's just that. And secondly, I just wanted to make the distinction between what I just did, which is adding and subtracting negative numbers, and multiplying and dividing negative numbers. When you're multiplying and dividing, for instance, if I have 3 multiplied by 2 multiplied by negative 4, remember that we kind of use this like canceling, but you know that 2 negatives, when put together, they make a positive. So for instance, this negative 3 multiplied by this negative 4 will give me a positive 12. And then when I multiply that by 2, I'll get a positive 24. Also, if you have one that is negative and one that is positive, your answer is negative. The rule I gave you was, if the signs are the same, better? If the signs are the same, your answer is positive, but if your signs are different, like in this case, your answer is negative. Okay, now that I've recapped that, the next thing that I wanted to remind you of was our rules for fractions. Now, I said last time that you can use your calculators to work out your fractions, and that is still the case. However, we're going to be moving on to algebraic fractions, and you will need to understand the basic rules of doing fractions, even though you can do simple fractions using your calculator. So just a reminder, if you have fractions that have the same denominator, like this one, you just go ahead and you add together the tops and get your answer. If you have fractions where one of the denominators is a factor of the other, use the larger number, in this case it will be 10, and turn the smaller one, turn the entire fraction so that the denominator is the same as the next fraction. For me to turn 5 into 10, I need to multiply it by 2, multiply the top by 2, and therefore this would turn into 2 over 10 plus 1 over 10, which is 3 over 10. Lastly, if you have two completely different numbers, you will have, let's say do 3 over 4 plus 1 over 3. Find the LCM of these numbers, the lowest common multiple. You can either think about the two numbers, think about all the possible multiples and find the smallest one that's the same, or you can multiply the two bottom numbers. In that case, I'm going to cross multiply the 2, and I'm going to get that 3 multiplied by 4 is 12. So my denominator is going to be 12. And I know that I will multiply each denominator by the other. So I'll multiply 4 by 3, and I'll multiply 3 by 4. Whatever we do at the bottom, we must do at the top. So my answer here will be 9 plus 4, and that will give me 13 over 12, which I'll have to write as 1 and 1 over 12. It's good. So we're going past the easy stuff. And now I wanted to give you some rules of indices. So there are a couple of rules you should know. This is something you should write. So the first one, which we know already, is that if you multiply, let me try to write it a little better. If you multiply a letter by itself, any number of times, you will write that letter to the power of how many times you multiply it by itself. We know that already. And we know the reverse. If I have
Excuse me, ma'am.
a to the power 2, that's the same thing as a multiplied by a. A to the power 1 is the same thing as just a alone. But a to the power 0 and anything to the power of 0 is equal to 1. That goes for numbers as well. I can choose any number. Suppose I choose the number 257 and I put that to the power of 0, my answer is still 1. Anything to the power of 0 is 1. We also need to know that a raised to a negative power, so suppose I have to the negative 1, is the same as 1 over a. The same goes for if I had a to the negative 2, that would be the same as 1 over a squared. Whatever the power, the negative power is, that power will go at, it will become the denominator, basically. But you remove the negative. All right, I'll give you a minute to write that because I want to go on. All right, so some more rules that you need to know. If you have two terms with the same base multiplying each other, so suppose I have a to the n just represents a number. It could be any number. It could be 3, 4, 10, anything. Multiply by another number n, then all you need to do, as long as they're multiplying and the bases are the same, the basis is the letter at the bottom. then all you need to do is add, n plus m. So when you're multiplying two indices with the same base, you add together the powers. Similarly, if you are dividing two indices with the same base, then you subtract your powers. And lastly, but no, there are two more actually. Another one you would need to know is if I have a letter raised to a power and I am raising that to another power, that's the same as if I'm going to multiply the two of those. So an example of that would be, suppose I have b to the 3, and I'm raising that b to the 3 to the power 2, my answer would be b to the 6, just to give you an example. This is the same thing for numbers. If I change this b instead to a 7, the answer would be the same. My answer would be 7 to the 6, just to let you know that. And the last one is, if I have an index that is raised to a fractional power, like this one is 1 on n, then that is the same thing as finding that root of that letter. So an example of that would be, I'm just going to put it over here in a little box. If I have a to the half, that is the same thing as the square root of a. And the reason is just the square root. The reason why I don't put anything here as I did here is because we know that the square root symbol on its own your square represents 2. It represents the root of 2. If I had a different number, however, for instance, if I had a to the 1/3, that would be the same as the cube root, where I have to put the 3 here now, of a. Okay, and lastly, just to combine the negative and the fractional, if I have a case where I have, let's say, a to the negative 1/4, that answer would become, we have to combine both, it will become a fraction, but at the same time, it will become the 4th root. Now, this is not necessarily something you have to memorize, they're just rules that you should know. This one here probably wouldn't give you, but I'm just letting you know what it is. But all the others are definitely something that you should learn. All right, so there's something else that I wanted to go over briefly, just a recap of how to multiply fractions. I can't remember if I did this last time, so I'm just gonna go over it again quickly. If you're multiplying fractions just on their own, let me put 5/6. If you're multiplying fractions on their own, what you're supposed to do is multiply straight across, multiply the numbers across. However, you need to check first and see if there's anywhere that you can cancel. So when we're canceling, we are dividing both the numerator of any fraction by the denominator of any other fraction. So by that I mean, I can either cancel the 6 with the 5, which I can't, but I'm just showing you how it would work. Or I can cancel the 6 with the 3. I can also cancel the 4 with the 5, or I could cancel the 3 with the 4, if there were numbers that could cancel. So the point I'm trying to make is, you cannot cancel across. You cannot cancel 3 with the 5. You can't do that. You can't cancel the 4 with the 6. That will not work. So if I'm canceling here, the only numbers I have that can cancel would be the 3 and the 6. So I would divide. I know that both of them are multiples of 3. So divide the 6 by 3 and divide the 3 by 3. Most people do this a short way. I would just put a line through it and divide it one time. So 3 into 6 will give me 2, and 3 into 3 will give me 1. Once I can't cancel anymore, then I go ahead and I multiply across. So when I multiply 1, 5, I get 5, and I'll multiply 4 now by 2, and I'll get 8, and that is it. So these are things that we would have known from primary school. I'm just going over before I go on to the algebraic fractions. In addition, if you're dividing, so if I take the same question and I turn it into a question that is division, we should remember that there are 2 steps. The first step is that you write back your first fraction, you change your division sign to a multiplication, and you flip the second fraction. So this second fraction will become 6 over 5. You go ahead then, from here, you do the same thing that you would have been doing before, which is to cancel. Anybody can tell me what numbers I'll be canceling? The 4 and the 6, correct? So I'll cancel here. I'll say, and I know that they're both multiples of 2. So I will say 2 into 6 is 3, 2 into 4 is 2. And I can't cancel anymore. You cannot think to cancel the 3 here and the 3 here because, again, you cannot cancel across. So I will just multiply. 3 3s would be 9, and 2 5s, would be 10. All right, so now that we have that covered, we're going to move on. Go back to these same notes. I would have mentioned to you that we were going to continue with this for this week and next week. So we would have stopped here. And what I wanted to also let you know is that I showed you the last class a way to try to work out a sum like this, but I put them one on top of each other, which we're supposed to do. So let me do that again. So I would have put, let's say, 12bc cubed d to the 4 over 4c squared d squared. And when I did this question, or a similar one to it, what I would have done is that I would have shown you basically the rules that I just explained. You can take away the powers of the d's from each other because remember I said once you're dividing, you can subtract your powers. Done the same thing with the c's, and we know wherever the answer is left back, that's where your letter will stay. But, so let me go through that again, just to show you in terms of the d's. I can see here I have more d's at the top than I do at the bottom. I know I'm taking away. I'll be left back with d to the 2, and I know that will be at the top. In terms of my c's, I will take away again. I'll get 1c, and I know that has to be at the top because they're more at the top. In terms of the b, there's nothing to cancel that with. I will leave it, and then I will just cancel my numbers. I'll say 4 into 4, 1, 4 into 12, 3, and my answer will just be 3bcd, bcd squared. And then there's no need for this line because it's no longer a fraction. None of my answers ended up at the bottom. What I wanted to show you here was that if for any reason this is confusing for you, feel free to do what was done in the example, which is that they wrote it out. So here you would see, let me see if I could increase the size of this a bit. So I'm speaking about right here. So here you will see they multiplied out. We know that c cubed is the same thing as 3 c's multiplying each other, and d to the 4 is the same thing as 4 d's multiplying each other, and they would have done the same thing here. We call this expanding. And if you choose to expand it, then all you would do at this point is that you will cancel them almost like how we were canceling just now. So you will come here and cancel 1d with 1d at the top, another d with another d here at the bottom. There are no more d's to cancel because the only way you can cancel is if there's the same thing at the top that there is at the bottom. C's, I will cancel 1c here with 1, 1 with another, and then there's no more c's to cancel. Do the same thing here, 4 into 4, 1, 4 into 12, 3. And now to get your answer, you will put back your 3. You see here you have a b and a c. And you have 2 d's, which is the same thing as d squared. And you notice there's nothing left at the bottom. So I just wanted to clarify that. So it's optional how you choose to work it out. I'm just showing you both ways. All right, so the next thing that we're going to do is cancellation. Well, right, we did the cancellation of fractions already. I don't think I need to go over this again. Just note that cancellation is only allowed when the operation is multiplication, and by default, division and multiplication are kind of the same thing. We went through this just now in terms of changing the sign. The reason why we went through this as it was because I thought that these notes here could have been a little bit confusing. But essentially what they're doing here is the same thing that we would have just done. If we have 12 over 30 and we're canceling, we will say 16 to 12, 2, and 16 to 30 is 5, and get the same answer, 2 over 5. They're just showing you what was the number that they used to divide, what is it a factor of. All right, so we have a more difficult problem here, and that's where we are going to start today. So we have 7 over 8. I'm just going to switch to Jamboard quickly. So we have 7 over 8 multiplied by a half, subtract a quarter. Minus 1 over 8 over 5 over 8. Multiplied by 1 and a quarter. Okay, so when you're working out a question like this, what you need to do is work out the top, work out the bottom, and then you would divide your two answers. Remember that this line here just means to divide. So you're going to work these out as if they were two separate sums and divide the two answers that you're going to get. Now, if we're starting with the top, then if you remember BODMAS tells you to work out what is in your brackets first. So we start with a half minus a quarter. I'm going to rub out this working as I go, so write it down if you so desire. And we know that once we have two denominators, one is a factor of the other, we leave the one that is larger. And basically, we will want to turn 2 into 4. So I will multiply 2 by 2, and I'll do the same at the top. When I do that, I'm going to get 2 at the top minus 1. My answer here is 3 over 4. So now I have that answer. I will go and I will take my brackets and I will replace them with the answer I worked out, which is 3 over 4. So I'm going to write that back over down here. So I'm just going to write over the top because I'm just doing the top first. So I have 7 over 8 multiplied by my answer, 3 over 4, minus 1 over 8. Right. Now, BODMAS also tells you that before you make either subtraction or...
Excuse me, ma'am.
Go ahead.
You had in the thing just now, you had 2 minus 1 equals 3. I'm missing.
I understood what you just said.
For the half minus a quarter, you had 4, and then you had 2 minus 1, and then your answer was 3 over 4. It should be 3 over 4.
It was 3 over 4, yeah.
So I am adding 1 to the 2.
So this is what let me see if I made a mistake. Hold on.
Okay.
Half, that's a quarter.
You're multiplying.
Multiply by 2 and multiply
by 2.
I didn't make a mistake. So it should have been 2 minus 1 over 4. So my apologies, your answer should have been a quarter. Thank you.
You're welcome.
So it really should have been 1 quarter. My apologies. Right. So as we were saying, Bodmer says that after you work out your brackets, the next thing you should do is to divide or multiply. So we have multiplication here, and multiplication obviously would only be for the first part. And is there any way here it can cancel? Can I cancel the part of the sum that has multiplication in it?
No.
No. Right. I can't cancel the 8 with the 4 because, as I said, we cannot cancel sideways. So we're just going to multiply across. So for this part that I have here highlighted, I will just get 7 ones are 7, and then I will get 8 fours, which is 32. And now I will just take away from that 1 over 8. Now to work out this last part here at the bottom, I'm just going to put this, let me put it up here, give myself some more room. So the last thing I'm going to do for the top is, again, I can see that one of my denominators is a multiple of the other. So I will put that one back. I'm going to use 32. So I'm going to put back the 7 here from the 32. I'm not going to manipulate that. But I know that to get, yes, that's correct. I know that to get 8, so I need to multiply it by 4. And therefore, I'm also going to multiply the top by 4. So I'm going to end up with 7 minus 4 over 32, which is going to be equal to 3 over 32. Let me just double check that my working so far is correct. If it is. Right, so 3 over 32. So now that we've worked out the answer for the top, I'm going to put it back up here and put it in a different color. So we worked out 3 over 32 for the top. Now it's time to work out the bottom. I'm going to erase this now. So now that I'm working out the bottom, we have 5 over 8 multiplied by 1 1/4. We will have to know that we cannot go ahead and multiply straight. We will have to turn this proper fraction into an improper fraction. And just in case you don't remember, to do that, I can hear somebody's mic on. Right. In order to change this into an improper fraction, I need to multiply my whole number by the bottom and add on the number at the top. So 4 ones will give me 4, add on 1, I'll get 5 over 4. That would be the same if I had, for instance, 2 and let's say 3 over 4. You'll multiply the 2 by the 4 and add on the top. 2 4s are 8, add on 2, that will be 11. So I'm going to go ahead now and I'm going to work this out. Again, can we cancel here? No. There's no way that we can cancel because you can't cancel top or bottom. So we go ahead and multiply. 5 5s are 25 and 8 4s again are 32. So our denominator now, the answer for here would be 25 over 32. So my last step now would be to work out this sum, and I'm going to write it a little bit better. Instead of having this line here that represents my division, I'm actually going to write a division sign. So I'm going to rewrite this as 3 over 32 divided by 25 over 32. They mean the same thing. So we're going to go ahead and use our rules of multiplying and dividing. Write back the first term, change the division to a multiplication sign, and invert the second term. So we're going to get 32 over 25. Now in this case, can we cancel? Yes. And we can cancel the 32s with each other. And we'll just get 1 and 1. We can't cancel the 3 and the 25, so that person online was right. Your answer is 3 over 25. I hope that was clear. Any questions?
No, please.
Hi, ma'am. Can you go over from the second denominator? Or you go to the second denominator?
So remember that decimals and percentages are other ways of writing fractions. 0.3 is the same thing as 3 over 10. If you remember your place values from primary school for decimals, remember that if I have a decimal, for instance, if I have 0.3576, you know this is your ones column. You know this will be your tenths with a THS at the end, your hundredths, thousands, and tens of thousands. I don't think I need to do that, but I guess I could just write it here. Those place values determine what that fraction is. So for instance, the 3, if I didn't have the rest of this number here, because the 3 is under tenths, then that would be 3 over 10. If I change that now, and if I had just 35, the 35, the last digit is under the hundredths column, so that would be 35 over 100. That is that fraction. And you continue to go on that way. If I had the 375, if I was just using this part, that is thousands, so that would be 375 over 1,000. And then the last one, the entire number will be over 10,000 and so on. So that's just a point to note. So here we just had 3 over 10. And we can change from decimals to fractions and to percentages. Once you have turned that decimal into a fraction, all you need to do is multiply it by 100 to get any decimal. In addition, decimals are also normally written in this form. They're normally written as a number. You can write them, sorry, as a number that has 2 digits after the decimal point. So by that I mean, if you have the decimal 0. Let's say 61, you can look at that. If you have to multiply that by 100, you know that's 61%. If you have to look at this fraction, sorry, this decimal, that's 7%. If you look at 0.5, if you take that, put a 0 after it, that's the same thing as 50%. So that's just points to note. So the same thing is already written here for you. And whenever I know I'm doing any questions and I have given percentages, I automatically just change it into a decimal. It makes it a little bit easier to work out. Or you could use it and work out the long way. So in my calculator, for instance, for this question, I would just put in 0.45 and multiply that by 320. You will get the answer for your percentage, because this is the same thing as 45 divided by 100. And we know that because this is your tenths, this is your hundredths column, so 0.45 is the same thing as 45 over 100. But you can work it out the longer way, and you can put your 45 by 100. Anytime you see the word of, it means to multiply. So you will multiply it by the other number given, which is 320. And you can choose to cancel. So let me go through that. 45 divided by 100. 45% of 320. So we have 45 over 100 multiplied by 320. And when you're canceling here, you can just cancel these zeros easily. cancel any zeros at the bottom with the same amount of zeros at the top. Then we'll have 10 and 45. I will cancel that by 5. So I'll get 5 into 10 is 2, 5 into 45 is 9. And then I'll do 2 and 32. So 2 into 2 is 1, and 2 into 32 will be 16. And now I will just multiply 9 by 16. I will choose not to do that in my head, so I want to work it out quickly, which is 144. So like I said, alternatively, you could have put in your calculator 0.45, multiply it by 320, and you will get the same 144. Am I moving too slow for you all? Yes? No? No? Okay. I don't have a good gauge of how much you all understand or not. That's why I have to ask. Okay. People online say no too. All right. So back to where we were. So we have an example, and just remember that anytime you see your percentage sign, make it in your mind now that you're either going to do one of two things. From the time you see that percentage sign, you will either write that number over 100, because that percentage, that sign here, represents that that number is over 100. So either choose to put it over 100 or just turn it into the relevant decimal, which in this case will be the same as 0.62. So you make it your mind, you choose one, and you work with it. So we have here that, let's move this one here. 38% of the students registered for math have to write Econ 10101. 124 of the students who are taking math are not doing Econ 0101. How many students have registered for math? Just read that again. 38% of the students registered for math have to write Econ 0101. 124 students who are taking math are not doing Econ 0101. How many students have registered for math? Okay, so we know that the amount of students who have registered for the class represents your full 100%. All that you have represents 100%. So the amount of people that would not have been registered for the class would have to be the percentage who are registered taken away from the entire amount of people who were registering. So we just take away those percentages. Let me make sure I explain that a little bit clearer. So it says that 38% of the students who are registered for math have to write this subject. They want to know how many students, hold on. Right, so they want to know how many students have actually registered. That is a percentage and not necessarily a number of students. So what you're trying to figure out is what's the actual number of students who have registered. You know the amount of students who have not registered. So what you're going to do is you're going to take your whole, which is all the people who have registered for either math or Econ 101, which is your 100%, and you're going to take away the percentage of persons who have registered for Econ 0101. So when I do that, I get 62%. You can take away percentages as long as they're both percentages. So we know that 62% of students are not registered, and therefore the question also told us that the students who are not registered are equivalent to 124, which means that that 62% is equivalent to 124 students. So if you want to work out how many students are registered for math, what you would need to do is that you would need to invert this in such a way that you work out what 100% is. Let me do another example before I come back to this one, because I can see that I am confusing you a bit. So let me give you an easier example. Let's say, for instance, me see. So let's say, for instance, in this class, let's say that 40% of the class are males. And let's say that there are 120 females. Suppose I ask you, how many males are in the class? So I've given you the percentage of people who are males. I've given you the number of people who are females. I want to know the number of persons in the class who are males. Now, there's no way that you can work this out just using the numbers that you are given, because you have absolutely no idea how many people are actually in this class. So what you would need to do is that you would need to figure out, use a different color. You would need to figure out what percentage this 120 is equivalent to. So if you know that 40% of the class are males, then what percentage will be females? What would you do? Just take it from 100. So you would know that the females would be equal to 100 minus 40%, which is 60%. And since you know the number of females, you can say then that 60% is equivalent to 120 females. Or let me just put students. But that's not what I asked. I asked how many males are in the class. So what you would need to do is that you first need to figure out how much is 100% of the class. In order for you to figure out what 40% is, you would first have to figure out what is 100% of the class. So what you would do, let me just go on to the next page. If I know that 60 over 100 is equivalent to my 120, then what I would need to do is to invert this. So I can work out that 100 on 60 multiplied by 120 will tell me how many students are in the entire class. It would tell me what the 100% of the class is. Are you following me? Okay. Just double check something. Right. So the way to look at this is whichever number is at the top, and well, let me put it this way. Because my 100% is now at the top, that is what I'm working on. I'm working out 100% of the class. When I go ahead now and I cancel and I work out my answer, I can cancel this entire thing and I will get that this is 2. My answer here is going to be 200. This tells me there are 200 students in a class. So now if I want to work out how many males are in a class, all I would have to do is to subtract. If there are 200 persons in a class and I know there were 120 females, then that means that there would have to be 80 males. The only step in here that might seem a little bit unfamiliar is this one. And all I need you to understand here is that if I know that a percentage is equivalent to a quantity and I want to find 100%, just take your percentage, flip it upside down, and multiply it by that quantity. That gives you your whole. That gives you the entirety of your class or whatever it is. It could be apples, oranges, whatever it is. Do I need to go over that again, or we got it? Okay, somebody said, can we repeat? All right, so let me do another example. Let's say that 30% of the class, let me find something else. So let's say that 30% of the class drives a car. And let's say that there are, let me find an easy number. Let's say that there are 100 people who do not. And suppose I ask you, how many persons drive a car. So again, you know what percentage drives. You know how many people do not. The only thing that you can do to work this out, you have two options. Well, your first option would be that you would take 100 away from 30% and get 70%. And this 70% would have to represent the percentage of persons who do not drive a car, because you know 30% of the people do. Once you have this 70%, we know that 70%, which is 70 over 100, is equivalent to 100 persons. So all you will need to do is invert this fraction and multiply. So you would get your entire 100%, which is what you're trying to figure out, which is all the persons, divided by 70, and multiply that by 100. It will cancel, and I'll cancel here. This is going to be a little difficult to figure out, so let me work it out on my calculator. Hold on. So we get 143 persons. So that means that your entire class in this case represents 143 persons. The question that you were asked was, how many persons drive a car? You know that 100 persons do not, and therefore 143 minus 100 persons means that there are 43 persons who do not drive a car. Sorry, did I mess that up? Hold on. Sorry, so there are 43 persons who do drive a car. Right, so we were trying to figure out how much do drive a car. We were trying to figure out that 30%. And what we would have done here is that we would have worked out the 30%. All right, so I'm going to move on. We have a lot of ground to cover. So in this question here, I strayed away from this because the wording was a bit confusing. What they were trying to figure out here is there are a certain set of students in this example who have registered for math, and there's a set who have registered for Econ 101. The question really wanted to find out how many students there were in total, and therefore they did the same thing that I would have done here. Flip your percentage, multiply it by the percentage that you do have, the equivalent of the percentage you do have, and they got their total. This question was only asking about the total. Before I move on, would you like me to go over another example of that again, or are we clear? One more.
Yes, ma'am. Can you go over another example, please?
Sure. One more. So let me change the question a little bit. What if I say 10% of the persons in this class are wearing jeans? Suppose I want to know, I'm going to change it slightly now so it's less work. Suppose I want to know, or suppose I say that there are 50 persons not wearing jeans. Suppose my question to you is, how many persons are in the class? So 10% of this class is wearing jeans, 50 persons are not wearing jeans. How many persons are in the entire class? So again, if you know that 10% represents the people who are wearing, then what percentage would represent the people who are not wearing? What percentage would that be? 90. So 90%, this 50 persons here represents 90% of the class. This is the hardest part here. If you can figure out this part here, there's not a lot of work left to do. You know that 90% is equal to 50. I'll do it on the next slide. 90% is equivalent to 50. That means 90 over 100 is equivalent to 50. If you want 100, take your 100 that is down here at the bottom and think of it this way. If you want 100%, which is the whole class, the 100 would need to be at the top. If 90% here is at the top and that's equivalent to 50, I want 100% to be at the top so I can figure out what that is equivalent to. So I put my 100 at the top, the 90 goes at the bottom, and I multiply by what I know 90% is. And when I do that, I will get my answer. Let me work that out quickly. That answer is 56. Wait, did I write it out correctly? 100 multiplied by 50 divided by 90. Right, so that's it. All right, so we can move on.
Excuse me, ma'am.
Yeah, go ahead.
Okay, so basically we always put 100% at the top if we are trying to figure out how many persons are in a class or really and truthfully how many persons there were.
Yeah, so I just worked out how many persons were in the entire class. If I was working out, for instance, how many, this particular question was how many people are in the class on a whole. If I had given you a question where it said, let me look back at the question quickly. If 10% are wearing jeans, and I asked you to work out how many people are wearing jeans, then all you would have had to do is take that 56, and you would have subtracted it from the 50, and you would have worked out that 6 people are wearing jeans. But I didn't ask you that in this question. I just wanted to know how many people are in the class in total.
Okay, thank you.
You're welcome. Right. Now, a way to figure out if your answers are correct is that there should be proportional. So if I did ask you how many persons are wearing jeans and you went ahead and you did that, and you got 6 persons, now this makes sense, and here's why. If I know that 10%, if I know, that 90% is equivalent to 50, then 10% being equivalent to 6 makes sense. If you came and you got an answer here and you told me that 10% is equivalent to 56, you know something has to be wrong because 90% is clearly far greater than 10%. So make sure that your answers are proportional to what the percentages are, right? If you have 2 different percentages, smaller amount should go to the smaller percentage and so on. All right, I think we can move on from here now. We are looking now at simple and compound interest. Let me see if there are any more examples I wanted to go through with you before I go on to this consumer arithmetic. All right. I don't think so. All right, so we have simple and compound interest. Simple interest is paid on the original principal at the end of each year. It represents a percentage of the principal for 1 year. For example, a man borrows $1,000 for 1 year at 6% simple interest a year. What interest does he have to pay? If you remember your the formula that you would have used in secondary school, simple interest is always equal to P multiplied by R multiplied by T, and you always put it over 100. All right, and your P represents your principal, which is your dollar amount. Your rate, your R is your rate. So let me put it here. P is your principal, which is the money that is borrowed or the money that is saved. R represents your rate, which is your percentage, and T would represent your time, which is usually measured either in months, years, usually in years, but it can be measured in months or weeks. Now, even though it's written like this here, it's entirely the same thing, The reason why they can choose to write it in this format and not necessarily like this is because the time here is 1 year. So if I had to work this out using the formula that I have right here, I would put 1,000 multiplied by 6%, don't put the percentage sign, multiplied by 1 year and put that over 100. Now this one isn't really important because you know anything multiplied by 1 is itself. So if you look at this part of it, it's the same thing as what they have here. You'll get the same 60. My apologies if that looks a little bit confusing. But my point is just to show you that this and this is the same. I would stick to this formula here if I were you because it works for any amount of time. So we can see that in the next question. Suppose the money was borrowed for 3 years instead. How much interest would he pay? So let me move this. So suppose the money was borrowed for 3 years, and so this is still simple interest. As the simple interest is paid on the same principal at the end of the year, I will have I is equal to the same P by R by T on 100. My principal is 1,000. I'll multiply that by 6, and my time now would be 3. And when I work that out, I would get the same answer as what they're doing here. Now, the reason that they're not putting in this case, for this formula that they're giving here, the reason why they're not putting your 100 at the bottom is because the rate is a percentage. So when they just rate the rate, they're assuming that you know that percentages are over 100. We just choose to put it in to make your lives a little bit easier. So when I work out this answer, I will get 180. But the question is not just how much interest it is. The question is how much the person is owed. This is money that was borrowed. And everybody will know if you go to a bank and you borrow money, you have to pay it back with interest. This is the interest that is owed, and therefore you will have to pay back what you have borrowed in addition to the interest that is accrued on it. So your total amount will be equal to the amount you borrowed, which is 1,000, plus your 180 that you got in interest, which should be 1,180. So there's a formula here that looks a little bit more sophisticated. And that is entirely the same as the formula that we were already using. It just says that if you want to find the total amount one time, instead of going through these 2 steps or 3 steps that I would have done, all you need to do is to use this formula here, your principal multiplied by 1 plus your rate multiplied by your time. And you can choose to use whichever formula you feel more comfortable with. Whichever one you use, you're going to get out the same answer. Are we clear with that? Can we move forward? Now, compound interest is a little bit different. Compound interest, instead of you only paying interest on the balance in that case that you would have borrowed, compound interest is compounded every single year that you have borrowed it for. So your interest isn't just calculated on the total that you would have borrowed on its own, but every single year the interest is placed onto how much you've borrowed, and then you have to pay interest on what you have borrowed for that year, as well as the interest that you have earned or gained in that year. So we have an example, $4,000 at 6% yearly for 2 years with the interest compounded every 6 months. Before I do that one, let me do a simpler example. So suppose I have a question where I am going to have, let's say I borrow the same $1,000 at 7% per annum. So that per annum is the same thing as per year. Compounded for 3 years. No, let me just do 2 years. For 2 years. So here's what you would do. You would start with your same formula, your P by R by T, which is we made 1,000 multiplied by 7 multiplied by 2 over 100. I can cancel here. My answer should be $140. Now this is the interest gained in year 1. So you're going to put that subscript here down by the A to represent year 1. The total amount owed in year 1 is going to be equal to that $1,000 plus the $140 in interest that you would have gained. So that's $1,140. Now, in the second year, you are going to have to use back this amount of money owed. You cannot go back to your $1,000 because the interest is built up upon the interest that you would have gained before plus what you already owed. So in year 2, my formula now would be, this interest in year 2 would be $1,140 multiplied by 7 multiplied by 2 over 100. I'm going to write that out in my calculator. So that is $159.60. And now I will have to take the interest earned in year 2 or gained in year 2 and add it back on now to the amount of money that I had owed at the end of the year. So let me just put that here. So my solution now would be 1,000. This is my total amount at the end of year 2 will be 1,140 plus $159.60. And my answer would be $1,299.60. All right, so that's basically it for compound interest. But this example that is given in your notes is a little bit more complex. I see some, so I'll just give you a Now remember, all of this is recorded for you. What I did is that I tried to make the recordings a little bit easier for you to access. So I downloaded the recording and I posted it on a YouTube channel. So what I would have posted onto eLearning would be a link to the YouTube channel. The recordings, unfortunately, are started if people log on really early. So the last one, if you did look at it, you would notice that the recording is about 3 hours long, even though our class is only 2 hours long. So you'll have to search for where the class actually started and then play from there if you choose to watch it. Oh, in addition, I do not have office hours on campus. I have office hours online. If anybody has any questions, you can send me an email. And what I would try to do is that I can compile the questions that you have, and I will probably create a video and I could post for you with the solutions so that everybody could get that advantage. Outside of that, you could also answer questions at your practical or the tutorial. All right, so back to the example that we were doing. So we have here an example. We have $4,000 at 6% yearly for 2 years with the interest compounded every 6 months. So if the interest is compounded every 6 months, you know that in a year there are 12 months, you know that that interest will be paid twice. So the interest will be paid 4 times, which is twice each year. Your interest payment, therefore, will be divided. So this 6%, I should have probably chosen another number, but this 6%, if it is compounded every 6 months, we will have to divide that by 2 because the first 3% will be paid in the first 6 months and the second 3% will be paid in the second 6 months of the year. So we're splitting the interest so it can be compounded every 6 months, which is the same as twice a year. So for our example, what I will start by doing is that I will work out the interest at the end of the first period. The interest at the end of the first period, which would be 1 year. Let me check something a minute. Hold on.
I think you do that wrong, man. I think you did that wrong.
I made an error here.
I know.
Pardon? So I know I'm looking back at this. Please change this. This should have been 1, and this should have been 1. So change that for me, please. The reason why is if you're working out compound interest, you have to work out on a year-by-year basis. So that shouldn't have been 2. That's an error on my part. It should have been 1 year at a time, even though it's being worked out for 2 years. We work out the answers for 2 years consecutively, hence why I worked out the interest twice. But the year, the time in years, is only 1 year at a time that I'm working it out for. So these answers will be incorrect, but you can choose to work those back out on your own. Follow the same steps, and you should get out your answers. Right? Right. So back here, again, this will be the same thing as if I did 4,000 multiplied by 3% multiplied by 1 year over 100. So I just want to show you that this is the same as this, except they eliminate this one here, this 1 year, because it's not necessary, right? So if you choose to do that, just remember that. You could just make a note of it somewhere. Compound interest, your formula is for 1 year only. So when you work out your interest at the end of the first period, which they get as $120, you're then going to add that on in the same way that we did. And then you're going to find your interest for the second period, which will be the new amount of money owed here. Multiply that by the same 3%, and you'll get a new amount of money. So this brings you to the end of year 1, because remember in this question, they're compounding the interest over 6-month periods. So this is only the first year that has done. So we move on then to the third period. Because we're splitting the year into 2, that means we have 4 time periods. We did the first 2 already. And if we continue and we do the third time period, you'll do the same thing again. And you will add on the interest that was gained onto the amount of money you had in the second time period. And that will give you the total principal for the third time period. And you just continue and so on. So let me just go over that one more time, because I feel that it may have lost some of you here.
Excuse me, ma'am. I have a question.
Go ahead.
Since we are doing it for 6 months, we will still multiply it by the 1 year period.
Right. So the thing is that remember that we have split the interest into 2. If you didn't split the
Yes.
interest into 2, then that would not be correct. But we are
Uh-huh.
paying out 6% over the space of a year, just for dividing that into 2 sets of interest over the 2 quarters. So that would be fine in this case. But like I said, you don't even have to put that 1. You don't have to put the 1 year, because it doesn't matter. What you have done is that you've already split your interest up into your 2 payments over the 6-month period, and you can just multiply your principal by that 3% interest. And alternatively, in terms of what you're asking, what you could have done is, if you didn't want to split this interest up over the 6-month periods, this is what you would have done. You would have had your same formula, PRT over 100. And what you would have done is you would have put 4,000 multiplied by the entire 6%. But instead, this time, 6 months, time is usually measured in years. So if you have a monthly time period and you want to change it into years,
Okay.
you have to divide it by how many months are in a year. So 6 months is the same thing as 6 divided by 12 years.
Yeah.
Right? So that 6
Okay.
months, I would have had to take my 100, and I would also have to divide it by 12. Let me write that on another board. Let's save myself some more space so I can explain what I mean. So I am doing 4,000 for just start a new one. I am doing $4,000 at 6% for 6 months. So what I'm trying to explain is my time must always be measured in years. To turn my time into years, I need to divide this 6 by how many months are in a year. So I could either choose to work out here or work out in my question. So I can come here and say, I know 6 divided by 12 is going to be the same thing as a half or 0.5, right? So that's the same thing as 0.5 years. If I do that, then when I'm working out my compound interest, I will have 4,000 multiplied by 6 multiplied by 0.5 over 100. Or alternatively, I could have left it like this, and I would have written it like this. 4,000 multiplied by 6 multiplied by 6 over 100, and I will let 12 also be my denominator, right? So that does the same thing that splitting my 6 months into two, sorry, my 6% into two 3% time periods does. It does the same exact thing. It just cuts it in half. It cuts the amount of time that is given in half, right? So whichever option you choose to use is fine. However, I would prefer that you follow what is given in the notes and just split the interest payment into half if that's the case. If it was a case where it was, let's say, if you had to split it in a smaller time period. So let's say the interest was paid, hold on. Right, so let's say instead the interest was compounded every 3 months. What you would have done in that case is that you would have split your interest payment into 4 different time periods. So you would have taken, so let's say, let me give you a different example. Let's say I have, maybe I could do this one for you, that way you're less confused. So let's say I had $4,000 at, let me see, let's say 8% for compounded every 3 months for 2 years. So if you were doing a question like this, you would start with this is year 1. So I'm going to put interest in year 1. The first thing I would have had to do is that I know if it's every 3 months, that means I'm paying interest 4 times in a year. So this 8%, all I would have to do is to divide that 8% divide that by 4, and I would have gotten that my interest would be split up into 4 sets of 2%. And this 2% will be paid out every 2 months, or it would begin every 3 months. So my question now would become, or my solution would become 4,000 multiplied by 2%, or 2 over 100. Are we following, or are we lost? Okay, so if you work,
Yes, but what I was thinking is that since that the 12 months is 1 year and 6 months is basically half a year, that you would have multiplied by the 0.5 instead of the 1. That was just my thinking.
right, so the problem that comes there with compound interest is that
Mm-hmm.
if you work it out for the entire yearly time period, you will actually
Mm-hmm.
on some of the compounding.
Okay.
Because remember, you're compounding it each month, each time period. So you're compounding every 3 months. So what you would end up doing in that case is that you would only compound your interest in a yearly time period, even though you're dividing it by 2. You will still
Okay.
compound interest for a yearly time period because you've converted that into years. So what you're doing there is
Okay.
still simple interest. That will be fine for a simple interest question, but for a compound interest question, you need to compound it the amount of months or the amount of times that it should be compounded in a year. Do you understand the difference between the two?
Yes, please.
So if I had to work out this question, my answer here would be 80, and that would be time period 1. How many time periods will we have in this question? Anybody can tell me? 8.
4.
So what you would do is your total amount, this is only for year 1, would be 4,000 plus 80, 4,080. You would do it again for year 2. There's interest in year 2. It'll be 4,080 this time. Multiply by 2%. You'll get your answer. You'll work out the total amount for year 2 by getting whatever answer this here is and adding it back on to 4,080. And you'll repeat that 8 times. Now, I wouldn't ask you to do that in the exam. That's exorbitant. But it might split it into 2 times a year and ask you to do it maybe for 2 years. Hopefully that's clear. If somebody wants me to work this out just so we can see how these steps go, I'm not going to do all of it, but I'll do this one. So that's 4,080 multiplied by 0.02, and that gives me 81.6, and then my total amount will be 4,080 plus 81.6, and that would give me $4,161.60. This would become your new total, your new principal, and you would just keep going on and on like that. All right, moving along. Right, so that covers that. Like I said, this is a formula, once again, that gives you the same result. And if you want to choose to use that, that is entirely up to you. Okay, so we're going to move on now to BODMAS again, and ordering of operations. So usually I ask students to write it going down like this. It just makes it a bit easier to see what your order should be. So at the top, oh, and I normally change this. Excuse me. I normally change the O to be an I. So you can write that. The I represents indices. And the indices are what all the rules I just gave you about the powers, those are indices. So normally after you work out brackets, if you have any indices in your question, you would work those out. So this just gives you the order. The first thing you do is your brackets, then you do your indices, then division, then multiplication. And as for addition and subtraction, it's not necessarily a case where you do addition first and then subtraction second. You do them together and you will work them out the same way that I explained to you to work them out before. So we have some examples, and it says we have 2 plus 3 multiplied by 4. And to note that there are multiplication sign, there's a multiplication and an addition sign in this expression. So according to the above rule, we must work out our multiplication first. So if you have your 2 plus 3 multiplied by 4, you must work out your multiplication before you can even think about addition. So you will get 12, and then you will add on 2, and now your total would be 24. So we have a harder question here. And we have 2, we're doing this question now, 2 minus 6. Let me go and jump. I could do it right here. So we have 2 minus 6 multiplied by 3 plus 20 divided by 4 minus 8 plus 15. So we don't have any brackets. So the next thing that we have to do would be to look for indices. There are none. The next thing would be division. So we will work out our division. And your division here is 20 divided by 4. That gives you 5. And what I prefer is that if you do these questions, or when you do these questions, keep your solutions coming systematically down. It makes it a little bit easier for you to follow what you're doing. So for me personally, I will put back everything else. Everything else other than what I have already worked out here. And then I would do the next step. And the next step would be after division comes multiplication. So I will multiply here. I'll get 18. I'm going to put back everything else that is not what I have worked out here. Now I'm at the stage where I only have addition and subtraction. And like I said, the A coming before the S does not mean do addition first and then subtraction second. You do either or, and you do them according to the same rules that I will just give you. So which ones are we going to combine and add first? You should use your negatives. So you have a negative 18 here. And we'll put those in brackets like I normally do. And a negative 8. And I know that I'm going to add those together and I'm going to put back the negative sign. So let me rub this out from here. That's just my working. Let me write it a little bit differently. Let me group my terms together first. So I'm going to put my negatives together. So that would be minus 18 and minus 8 being added together. And then I'm going to add together my positive numbers, 2 plus 5 plus 15. 8 plus 18, that should give me 26. Just going to write it here. That'll be a negative 26, because remember, these are two negative numbers that are added together. You can never add together your two negative numbers and get positive. And then,
Excuse me. Can you rewrite what you had at the bottom of the screen at the top? I can't see.
no problem.
Thank you.
You're welcome. So I was just rearranging this one, and I was putting my negatives together. So I had negative 18, and I also know I had a negative 8, and we know already that we can add those together and just put back a negative sign. And then we will add together all the positives, plus 2, plus 5, plus 15. And then when you do that, for this section here, you will get 26. So we will put back negative 26. And for this section over here, you'll get 7 plus 15, that's going to be 22. And remember, once we have two different signs, then we subtract them and put the sign in the bigger number. So that person all is correct. Your answer is minus 4. Okay? Do I need to do another one of those, or are we good with that? I'll assume we're good.
We're good.
So moving along to the next one. So we have 10 minus 3/4 of 12 plus 6 plus 4 divided by 3. Now, this question looks a little strange because there's an of in the middle of it. Anytime you see the word of, that just means to multiply. So just replace it with a multiplication sign. So this sum is really the same as 10 minus 3 over 4 multiplied by 12 plus 6 multiplied by 4 divided by 3. So I'm going to do 2 at a time now, because you can basically do you can do your division and multiplication at the same time because they're not correlating to each other. So I'm going to do here, and I'm going to do here. I'm going to work out those two answers. Hold on a minute. Okay, so let's start with this one on this side. So we have 3 over 4 multiplied by 12. And I know that when I am multiplying, when I'm working this out, if I come to the side, let's say I do it right here, 3 over 4 multiplied by 12, and I'll just cancel. 4 into 4, 1. 4 into 12 is 3, and I'll just end up multiplying 3 by 3. My answer is 9. So when I rewrite this sum, sorry, I forgot what I was doing here. When I rewrite this sum, I will rewrite it as 10 minus, and this entire thing here would become 9 plus 6 multiplied by 4 divided by 3. Now, the division, which is what we could have done first, but if you notice, you cannot divide 4 by 3, so I chose to put it as a fraction, and therefore, I will end up multiplying it in the same way that I would have done this section over here. So just remember, this division sign is the same exact thing as me putting 4 over 3. Just like how I said, this sign is the same thing as just the plain division sign. So when I do that and I write it differently, now I'm going to be working out the 6 multiplied by 3. I'm just doing this portion because now I'm doing multiplication. Because I'm not considering this as a separate sum to do, but instead I'm using it as a dividend. So now I will cancel again, and I'll have 3 into 3, 1, 3 into 6 is 2, and then 2 4s are 8. So this entire section here becomes 8, and therefore my sum now becomes, I'm going to write this back, 10 minus 9 plus all of this is now 8. And what you could do here is that you could put this straight in your calculator, or do what I told you to do. Put together your positives and your negative. You only have one negative, but you have two positives. So you're going to add together your 8 and your 10. That's going to give you 18. Sorry, I forgot that somebody said they can't see at the bottom. So let me write that back up here. So you're going to have your negative 9. Let me bring that around, hold on. So we have 10 minus 9 plus 8. So remember, we group together the positives and the negatives. There's only one negative, but we do have two positives, 8 and 10. So that is going to work out to be the same as negative 9 plus 18. And what we know again about having two different signs, we subtract, put the sign of the bigger number. So this answer is going to be 9, but it's going to be a positive 9 because 18 is a larger number and that is also positive. So the only hard part about this question was maybe looking at the beginning here, thinking to yourself, well, the first thing that I know that I'm supposed to do in this question is division, but I cannot possibly divide 4 by 3. So just know that you have that as an option to be able to turn that into a fraction. Okay? And go ahead and work it out like that. Do I need to do another example like that, or are we clear? Okay, now on to something a little bit more fun. So we are going on to brackets and the distributive property. Now, just remember before we go on to this, remember your rules of multiplying negative and positive powers. Remember that if you multiply two negatives by each other, you're going to get a positive. But if you multiply two different signs, you're going to get a negative. Okay, so just.
Ms. Ford, sorry, excuse me a second. I wanted to just go back. Could you go back up to the last part you did before? Okay, where I'm seeing minus 9, and I see is there something next to it? Or
I didn't hear that.
I see where I see 9 minus 9, and I see 18.
Right. All right. Let me.
Like there's a sign or something next to the 9. I wasn't sure if that's something that right in that section there. I saw next to the 9 minus 9 is that That's like as a plus sign.
Yeah, let me write it again. So what it should have been, so you can ignore this. What it should have been is just 9 plus 18. Right, negative 9 plus 18. And then it would have gotten a positive 9. That's all that was.
Okay, thank you.
All right. Now, in terms of brackets, no, in general, before I get to these slightly harder ones, anytime you have a bracket, so let's say I have two open brackets, A plus B. And let's say I also have M, open brackets, N plus, let's say P. And let me put minus. Anything that is on the outside of your brackets mean to multiply. And it's telling you, multiply whatever is on the outside of your bracket by everything on the inside of it. Each term on the inside must be multiplied by whatever term is outside of your bracket. So when you see brackets, think multiplication. Not multiplying inside, you're not multiplying these two together, but whatever's here must multiply both. So when you work out your answer for this first sum, it's going to be 2 first being multiplied by A, and that gives you, use some color coordination, make this look pretty. So it's 2 first that's going to multiply A, that's going to give you 2A, and then you're going to multiply the same 2 now, but by B, and that's going to give you 2B. In terms of what goes here, you put back whatever sign was in the middle, you put that back, unless you were multiplying by a number that was negative, and that's not the case. So you don't have any positive or negative terms to work out here, and that's entirely it. If I do the next question, the M will first multiply the N. When we're doing questions like this, you don't put our equation, our equal sign at the beginning instead of at the end, and you would have MN. Because remember that M multiplied by N is the same thing as just MN. Remember, we don't write multiplication signs in algebra, we just stick them together. That means they're multiplying. So we subtract now, and we take our M, and we multiply it now by the other term, and we get MP. And that is your answer. The same thing applies if we have multiple terms. So suppose we have, let's do some signs. None I'm not used to. So if I have 3 by A minus 2B plus 4C. So I was doing a question like this. I have to multiply each term by what? Anybody can tell me? By the 3. So you will be multiplying the 3 by the A, you get 3A. Put back your sign. Then you multiply the 3 by the 2B, which gives you 6B. Then you multiply the 3 by the 4C. Put back your plus sign here, that comes from up. So all these things are coming from up above. And you get 12C. So let's vary that now, and let's include some negative numbers. So if you have, for instance, let's say I have, let me do the same sum, but this time I'm going to make it a negative 3. So you have a negative 3 multiplied by A minus 2B plus 4C. What this negative is going to do is that it's going to reverse all of your signs inside of your bracket. So we're going to have negative 3A this time, because it's a negative 3 by A. But now we have negative 3 multiplying a negative 2B. So what happens with these two signs here? They become a what? Positive. So it's going to become now a positive 6B. So if I go, let me take some of that off of there. So that's a positive 6B. If I go on now to the last term, it is a negative 3 multiplied by a positive 4C. And like I said, once your signs are different, your answer is negative. It's only when the signs are the same, your answer comes out to be positive. So then we're going to have here our -3 by our +4 different signs will give me, sorry, a -12C. So if you look at the answer that is given here and compare that to the answer that's given here, you will notice that the difference between the two sums is that the signs are reversed. If I'm multiplying by a positive number on the outside, my signs inside will stay the same. But if I'm multiplying by a negative number on the outside, the signs inside will be reversed. They will switch. All right? Okay. So let's go back to the examples that we have. So we have here, in this question, we have -A, sorry, brackets, negative, we have just a negative multiplied by A minus B. So if we notice here, there is no number at the front. There's no number by the brackets. You just have a negative there. What does that mean? If I don't actually have a number multiplying, it's 1, correct. It's a 1 here, but we don't need to write it because we know when we multiply A and B by 1, we're still going to get back A and B. So just make a note of that. So we can just go ahead and work out, essentially all you're working out here is your signs. And if you understood what I just told you, you would know that this negative being applied to this positive A will give me a negative A, and the negative now with the negative B will give me a positive B. So essentially what you would have done is you had in your brackets a positive A and a positive B. What the negative comes and it does is that it makes both of them, sorry, I have the wrong thing. Let me change that. So instead of your brackets, sorry, you had a positive A, but a negative B. And what your negative sign on the outside does is that it turns this A into a negative number, no, and it turns the B into a positive number, no. So it's the same thing in terms of reversing the signs. Okay? So we have another example. We have -2 by C plus 3. Not yellow. So we have -2 by C plus 3. And in this case, we would have -2C. And now when we apply this and multiply it by this, we will get a -6. And that will be your answer. Now there's something that I forgot to mention when we were combining like terms. I remembered it before, but I forgot to say it. If we were combining like terms and we had a question, for instance, like this, and I'm telling you this because there's a question coming like on your tutorial. So if we had something like this, and we are combining like terms, can anybody tell me in this question, if you do remember, what would be the like terms? So I see somebody said 2A
A and 3A.
and -3A. Are there any more like terms?
Nope.
There are. So numbers that are alone,
6 and 2.
like these,
6 and 2.
these are automatically like terms. They're not algebraic terms. You don't have any letters. So when you combine it, you're combining your letters according to the same type of letters. Just understand that the numbers are already alike. Okay? So I just forgot to mention that to you before, so I said I will mention it again. So when you're working out this sum, you would work out and you would have 3A minus 2A. That would be, put my answer here, -A. And you would have -6 plus 2. And that would give you -4. So that would be your answer there. All right? So that's just by the way. All right, we are going to stop there. Anybody has any questions? Okay.
Yes, ma'am. Excuse me. Hello?
Go ahead, I'm listening.
Yes, please. At the beginning of class, you made a reference to the um, practical, and that it could either be done face to face or online.
I'm having a hard time hearing you.
No, I was saying that you said that the practical could either be done face to face or online,
Yes.
and it's going to be a Zoom link.
Yes, there's going to be a Zoom link for it.
Okay, so we don't have to state whether or not we want to do
No.
on. Okay, thank you.
Excuse me, you could just go back to the one you were doing before,
Sure.
the 2C.
Oh, you mean on the same page? Go ahead.
Yeah, I just wanted to see that one. Thank you. The one before the one what you had before, you have this one. I think is the one on page 4.
So you want to see the one I did before?
Yeah, well, before you got to -2C plus 3, you had something else before it. I just didn't get all that down.
So that was what I did before.
Okay, yeah, that's what I needed. Thanks.
Yes, there's going to be a Zoom link for the practical. Not necessarily, unless you have two options. You could either
just to question quick. So the compound interest, and the student reports with the formula, but there's a formula in notes. Is it that? We should use the formula or use what you're saying out there? Is there a midterm for this? Is there a midterm for this assessment? That was when? That will be when? Okay. One last thing. About the practicals, you said that the first doing it might be doing something using a device, and we should have a device with us, or we can actually do this. If we don't have a device, then what happens? You won't be doing this. You won't be using this setup. Oh. And it's not before. It's not before you can get them on the first semester. No, I just yeah, could be. But what I can do and become. Right, thanks.